So we're looking at a theorem which tells that the angle subtended by an arc at the center is double, so 2 times the angle subtended by it at any point on the remaining part of the circle. So first of all, what does subtend mean? We'll replace it with make, or if not made. Angle made by an arc. Angle made by an arc at the center is double the angle made by it at any point on the remaining part of the circle. So what does that mean? First we will talk about arc. So what is an arc? So we know circumference. So what is circumference? It is the boundary of a circle. So of the circumference, if we happen to cut some part of it, that gives you an arc. So here in this case, APB is your arc, and this is the minor arc. So if we consider, say, this arc APB. So if this is the center, the angle subtended by this minor arc with the center will be something like this. So if this happens to be, say, I'll explain that later. Then this arc subtends some angle with the remaining part in this manner. Right? This will become the remaining part, is it not? See, we are considering this part of the arc. So this is under consideration. So which arc? APB. So the remaining part will be, this is O, that's Q. The remaining part will be the other part. So this will be your remaining part. So that's AQB arc, or AMB, whatever it is. So what does the theorem tell? Say this is 2 times of x. This will be x. It will be half of it. Right? So this is your theorem. So now let's consider a case of major arc. So the arc subtended by the major part of the arc. The angle subtended by the major arc will look something like this. So this is the center. So this is the angle subtended by it. And with the remaining part, it will look something like this. So if this is, say, A, so this is, say, O, and say this is B, the angle subtended by the major arc will be at this side. Many people get confused. They write the other side. So you should avoid this. So remember, it always is more than 180 degree. Okay, this will be more than 180 degree. And the remaining part is at this point, right? So this will be your diagram. So in this case, if this is 2A, that will be A, right? So to make things clear, this is the part under consideration, right? So this is your Q part, and that's your P part. So this is arc AQP, and remaining part is your minor arc. Remaining part is APB. So if this is 2A, that's A. So let me put across an example. Say this is 220 degree. So this will be 110 degree. Say this is 80 degree, and this will be 40 degree. At the center, it will be double that of the circumference, whatever angle is subtended by the arcs with the circumference. So this is your theorem. I hope it's clear. Now we are looking at semicircle. So when you talk about semicircle, we are talking about an arc which is half the circle. So AB is your arc, that is half the circle. So this is say O, and this is your semicircle, right? So angle subtended by it with the center is a straight line. So what does this become? The diameter. So what is the angle subtended by it with the center now? This amount, that is 180 degree. Now, if we talk about the angle subtended by it with the center, how much will that be? This will be 90 degree. This is the difference. So this is 180 and that's 90. Okay, so this is a special case and you guys have to know this. So to end with, right, okay, let me actually write this. So in this case, the remaining part can be both the sides. So let me explain this. See, if the angle is subtended with this end as well, wherever, doesn't matter, all of this will be 90 degree. Okay, so remaining part is on both the sides. So this is your picture. So let me end with an example. Angle subtended by major arc will look like this. So I know I'm repeating, but I want to show you guys a case wherein the major arc is inverted. So this is your arc under consideration, and the angle subtended by this arc with the center will look like this, and with the circumference it will look like this. So if this is say 240 degree, this will be 120 degree. So that's A, that's B, and that's right Q, for example. So this is your remaining part, that is AQB, and that's your under consideration part. So that is say AMB. Okay, so yeah, you need to understand that when we talk about major arc, the angle subtended by it at the center will look something like this. Right, it will be part of the major arc region itself. Right, major sector basically. Okay, so this part will be in the major sector. Here too you can see it is part of major sector. So this difference I want you guys to understand. Right, the difference between these two diagrams. So many people get confused. So please don't get confused. So what you have to do is pause and write everything on the screen. Nothing has to be missed. Do it once, do it with proper geometry set. Write it neat and write 4 diagrams. Do it once and the rest of the syllabus becomes simpler. Chapter syllabus, that is. Okay, so pause and copy this off.